not mandatory. It is not compulsory. You're required to do it. Let's observe it, guys. Okay, if you look at this, we have two classes here. One is load parent and one is load child. In load parent, you declared a method called a test, and in load child, you have overloaded that method. What we have done? Overloaded the method. So, understand what we have done here? We are overloaded parent classes test method in child class. Understood? This is what we have done in the previous session. We have overloaded the parent class test method in the child class. Same way, let me come to load parent. And here, I'll add a new method, guys. Public virtual void show. Public virtual void show. Yeah, I'm writing a method here. Public virtual void show. So this method is declared as virtual. And remember, once you declare virtual, it is overridable. This method is overridable. And I'm writing here console.writeLine parent class show method is called. Understood, huh? So I declared the method as virtual. And now let me go to the child class. And in the child class, what I can do, I can overload this method. Sorry, I can override the method. But overriding is mandatory and optional. Let me preview. C.show. C.show. I'm trying to call this method now. Which method? The method show. And this is a clear proof to you. Overriding a parent class's method under the child class is only optional but not mandatory. I repeat, this is a clear proof to you to tell that overriding a parent class method under the child class is only optional. Ignore the 1 and 2 methods here. 1 and 2 methods, the discussion is over in the last session already. Only focus on the third method. What is the output? And you understood now, the method is declared virtual but did not override in the child class. And this is telling you overriding is not mandatory. Overriding is only optional. You may do it or you may not do it. But you are given a chance to do it. Understood or not? What is that? You are given a chance to do it. You will do or will not do is completely left to your discretion. Okay, so you can watch it. I declared the method as virtual, but I did not override this method in the child class. Shall we try overriding this now? Okay. What do we want to do? Overriding parent class show method in child class. Understand the difference here. What are you doing in the first case? We are overloading. What are we doing in the second case? We are overriding. When you're overriding, just listen to this. When you're overriding, all of you carefully observe. When we type here override, listen all of you. When you type here override, it will immediately show you the list of all the methods in the parent class that can be overridden by the child class. Did you understand me? It will immediately show you the list of all the methods in the parent class that can be overridden in the child class. Now, look at that list and tell me, what did you understand from that? What did you understand from that list? Yeah, that is what you should understand. Equals, get hash code, and the two string methods of the object class are also virtual. Well, remember, day before yesterday we discussed like what is that? Object class provides you 4 methods for consumption. What are the 4? Equals, get hash code, get a type, toString. In that 3 methods are virtual now. What are the 3 methods? Equals, get hash code, toString, except get a type, except get a type. The remaining 3 methods are also virtual. Do you know if overriding is mandatory? Do you know what is the problem? If overriding is mandatory, every day you need to re-implement those 3 methods now. Understood or not? If overriding is mandatory, from day one, you need to re-implement the 3 methods. What 3 methods? Equals, get hash code, toString. But overriding is only optional, but not mandatory. That is a chance given by the parent to the children, which the child can utilize it or ignore it. Understood? So first, the child has ignored it and called the show method directly. Now the child is utilizing that particular feature. What is it? It is trying to override the method. Okay, simply select your method, guys. Simply select your method. Once you select the method, it will write the body. It will write the body. What is it doing? It is internally calling base.show. Already I explained about the base keyword. Base refers to parent class. Means what is it doing? Base.show means it is calling the parent class show method now. It is calling the parent class show method. It is internally simply calling base.show. When I say base.show, it is immediately calling the parent class's show method in this context. Is my point clear, all of you? Yes or not? That's what exactly it is doing. So it is calling, but we need to change that logic. Array, if I call show, it will call base.show. Again, the parent class method only will execute. But we are doing this action for re-implementation. Understand? We are doing this for re-implementation. Come on, let's re-implement the logic. What I want to write is console.writeLine child class show method is called. Are you clear? What is that? Child class show method is called. And what's the third output again? What did you get it earlier? Earlier, parent class show method is called. What are you getting now? That is what I said you. This is changing the behavior. What is this? Changing the behavior. Overloading means re-implementing overloading means multiple implementations. See that overloading 2 methods are there. Parent also executed. But overriding means not multiple behaviors, man. What is it? Changing the behavior. That is why earlier what executed? Parent class. Now what is executing? Child class. We are changing the behavior. The concept is like this, man. See, right now in your home, you have some occasion like your birthday or some festival, some occasion. Your parents have bought you a pair of new clothes. Your parents have bought you a pair of new clothes. So they have given them to you. They have given them to you and said you one thing. What is that? We have bought them according to our taste. We have bought them according to our taste. If you like it, well and good, wear them. If you don't like them, here is the bill. Go exchange and get whatever you want. Got it or not? Okay, so they given the bill to you and telling you go and exchange and get whatever you want. Now you think wise, you have 2 options before you now. What are the 2 options? Come on here, open the mouth. Option 1, where what is given by them. Where what is given by them. Second option, go exchange and get whatever you want. Are you clear? But see, if you like it, you don't exchange it. If you like it, you don't exchange it. You wear it like that only. If you don't like it only, it's also same, man. Parent class defines a method and gives to the child class for consumption. Parent class defines a method and gives to the child class to the consumption. And telling the child class, this method is implemented according to my requirements. This method is implemented according to my requirements. If you don't like the behavior of the method, I'm giving a chance to change the behavior according to your requirements now. How is it telling? It is telling that by declaring it as virtual. Like your parents are telling you by giving the bill. The bill, without the bill, you cannot exchange now. Same way here, it is given as virtual. So once this virtual is used on the parent is giving a permission for the child now. For what? Either to consume or change. Consume it or change it. So choice is yours now. First, what we done? We consumed it as it is. Later, what we done? We changed it. We changed it according to our requirements. I hope you guys are clear with the difference between overloading and overriding now. Overloading means multiple behaviors. Overloading means multiple behaviors. See, something like you started earning. But still, even though you start earning, you're always kids to your parents. Okay? For your birthday, your parents have purchased you a dress. And because you are earning, you too purchased a dress now. So you have two. One given by your parents, one what you purchased. That is called overloading. You have two pairs now. Okay? But overriding means parents have purchased and given to you, but you don't have money to purchase something new, but you have two options before you. What is it? Wear what they given to you or exchange and get whatever you want. Exchange and get whatever you want here. Is it clear? Understood? That is what the difference between overloading, overriding. Okay, fine. Yeah, coming back. A small question here. What the question is? Can we override a parent classes method under the child class without declaring it as virtual? Come on, yaar, there's a question, answer. Yes or no? No, you cannot do this. And see, guys, for confusing us, the question can be asked like this also. What is it? Can we re-implement a parent classes method under the child class without declaring it as virtual? Yesterday, what did we talk? Overriding means? Re-implementing. Overriding means re-implementing. Now the question is, can we re-implement a parent classes method under the child class without declaring it as virtual? The question can be asked like this also. What is the answer? Yes is the answer. How, sir, you're telling overriding means re-implementing? Overriding means re-implementing only. But re-implementing means not only overriding. Did you understand? Honda City is a car. But that doesn't mean that car means only Honda City. Yes or not? Honda City is a car. Does it mean that car means only Honda City? So many cars are there in the market now. Yes or not? Same point I'm telling you in a different way. Overriding means re-implementing. But re-implementing means not only overriding. So is there any other way to do re-implementing? Yes. We can re-implement a parent classes method under the child class in two different approaches. We can re-implement a parent classes method under the child class using two different approaches. One is overriding, what we already learned. Second one is hiding or shadowing. What is the second one? Hiding or shadowing. See, listen, yes, because we can re-implement a parent classes method under a child class by using two approaches. First one, overriding. Second one, hiding or shadowing. But here the question is asked, can we override? What is the answer? No, we cannot override unless the method is declared as virtual. Read the two question and answers carefully. First one, No, it is not possible unless the method is declared as virtual. Second question. It's not telling overriding. Can we re-implement a parent classes method under the child class without declaring it as virtual? And the answer is yes, because we can re-implement a parent classes method under a child class by using two approaches. The first approach is overriding, and the second approach is hiding or shadowing. Are you clear? The first approach is overriding and the second approach is hiding or shadowing. There are two different ways how you can do this. One is overriding, second one is hiding or shadowing. Hope I'm clear. Okay. So now what is hiding or shadowing? What is or shadowing? This is also an approach of re-implementing parent classes methods under the child class. Just like overriding. But the difference is in overriding, child class can re-implement parent classes methods only when they are declared as virtual, whereas in hiding or shadowing, child class can re-implement a parent's method even if it is not declared as virtual also. Read again. This is also an approach of re-implementing parent class methods under child class, just like overriding. But the difference is in overriding, child class re-implements parent classes methods only when they're declared as virtual, or otherwise child class can re-implement parent classes methods only when they are declared as virtual. Whereas in hiding or shadowing, child class can re-implement a parent's method, even if it is not declared as virtual also. No need to declare virtual, guys. What is the difference, Just look. Class 1. Public void display is a method. Is this method declared virtual? Come on, louder. Now this is class 2, inheriting from class 1. Can I override this method in the child class? Come on. Can I override this method in the child class? Understand the terminology correctly. Can I override? No chance. You cannot override. Why? It's not declared virtual. You cannot override. Okay. Can I re-implement this method in the child class? Yes, you can re-implement this method in the child class. How? Public new void display. What is that? Public new void display. See, just like we use override in the child class to tell we are re-implementing, we use new in the child class to tell we are hiding. Understood or not? Sir, you put square brace there. Yes, guys. Using new is only optional there. Okay, watch it. You'll understand much better. Let me go to parent class, and in the parent class, I'm writing a new method. Already we have two methods here. One method we overloaded, one method we have overridden. Correct? Now, public void display. Console dot write line parent class display method is called. So there is a new method defined in parent class. Now let me come to child class. Let me come to child class. And see guys, I'm calling that method. Watch the output of the fourth method. Watch the fourth output now. 1, 2, 3, done. Come on, look at the fourth output. What is the output? Parent class display method is called. Understood or not? But guys, I did not like the output of the method. I did not like the output of the method. So what is my plan? My plan is to re-implement it. My plan is to re-implement it. When I think of re-implementing, first thing what I think, can I override this or not? Can I? How do you check? Type override and see. If you get the list there, you can override. Type override and see guys, if you get the list there, you can override now. If you did not get it, then what is the meaning? It is not declared virtual. Then you are required to choose the second option. What is the second option? Hiding or shadowing. So guys, now see, I am doing the third one. What is it? Hiding or shadowing. Parent classes display method in child class. Got it or not? So now I'm writing public void display. Using new is the optional. I said you right. Now I'm writing here console.writeLine child class display method is called. Now also look at the fourth output again. Now also changing, man. Both are changing only. Overriding is also changing. Hiding is also changing. What is the difference? First one with permission, second one without permission. Let us talk the same previous scenario in a different way. Your parents has given a pair of new clothes to you, but they did not tell you to exchange. But once you open the cover, the dress what you have, the color you did not like. That is a old fashion. That's a very, very old fashion and you did not like it. And you found the bill inside the cover. So without informing to your parents, you went, exchanged and got what you want now. Did you understand me? In the first case, parents only said go and exchange. In the second case, they did not tell, but you went. You done it. You went, you exchanged and got a new pair of clothes. And you got a new pair of clothes because you did not like the existing. Now also same. The method is not declared as virtual in the parent class, but I did not like the output of the method now. So I changed it in the child class. Okay? Listen. Did I use a new keyword? There is a warning message. See? Warning. Greens are warning. What is the warning? The warning is the system is telling you or the compiler is telling you, you already have a display method in the parent class and you have written another display method in the child class. Be careful. This display method is going to hide the parent's display method. This is going to hide the parent's display method. And why that warning? The warning is to tell, are you doing this by a mistake or intentionally? Got the question or not? What is the question? Are you doing this by a mistake or intentionally? If it is a mistake, change the name here. Otherwise, parent class method will become useless now. If it is intentionally, tell. If it is intentional, tell me. How? See there, no warning. By using new, I am telling my compiler now. What I am telling? I am intentionally doing this action. I know that. Parent class also has a method called display. I am hiding that. Got it or not? See, you have a black color jeans in your wardrobe. But today you went to shopping and again purchased one more black color. Yes or not? After you purchase the new one and both in the wardrobe, your hand never goes onto the old one. Yes or not? Always what you pick is only the new and the latest. You never pick the old one now. So slowly that goes below your dresses in the wardrobe and becomes unused. Yes or not? He's also telling the same thing. Arre, this display method will hide the old one. Now, from now onwards, old one will be useless. Are you getting my point or not? So, by using the new keyword, I'm telling to my compiler, what I'm telling, I know that there is a display method in the parent class, and I am intentionally changing the behavior of that method as per my requirements. I hope I am clear. Understood, all of you? Yes. There is no point in. Uh, already the method is called off. Already this method is called off. Already the display method is called off somewhere now. If I write a method with a new name, I need to go and change the code there also. Yeah, implement. See, understand, you are talking completely new project. Think about an existing project now. The project development is completed. Parent class has a display method, and this method was called somewhere already. Are you getting my point? This method was already called somewhere. I called up this method somewhere. What output I'm getting? Parent class. We did not like it. What is your point? You're telling, why don't you write a new method? If I write the new method, I need to go and change this method name also there now. But if I simply change the method's logic here, I don't require to change the calling code now. The calling code will be same, but output will be different. That is why we do it. For everyone, new method only will come now. For everyone, new method only will come. It will affect off. See, scenario based. I want it only, I will do it. Okay, when I want it only, I'm going to do it. I'll show you. Wait, we'll see that when we use this overloading, when we use this overriding, I'll show you practically. Okay, we'll talk on that. Fine. So are you guys clear? Understood the difference between overloading, overriding, and hiding? Guys, I defined you two classes. In the two classes, I've explained you all the three concepts to you. This is the first class, man. Test, show, display. Now see, we overloaded this method in the child. Overloading. We have overridden this method in the child. Overriding. We have performed hiding or shadowing of this method in the child. Hiding. All three. So, this is what you have done. Just a second. Just a second. Hanged off. This is what you have done, guys. Load parent, public void test, public virtual void show, public void display. Load child. Inheriting from load parent. Public void test, int I. Overloading. Public override void show. Overriding. Public new void display. This is what I shown you all three things before you now. This is polymorphism, what I thought started yesterday. Three different options. Overloading, overriding, hiding or shadowing. All these things comes under polymorphism only. Okay. Now a small question. What the question is? See, we noticed after overriding or hiding a parent's method in child class, From now, child class in child class from now, when we try to call those methods, child class methods gets executed, but not of parent class anymore. Am I correct? We noticed it very clearly. Before re-implementation, parent. After implementation, child. That only said here. We noticed that after overriding or hiding a parent's method in child class, after overriding or hiding a parent's method in child class, from now, when we try to call those methods, child class methods gets executed, but not of parent class anymore. What is called? Child class methods are called, but not of parent class. Okay. So the question is, so is there any chance of calling parents methods from child class now? Means sometimes I wanted to use parents methods and sometimes I wanted to use child's methods. I want both. Did you understand me or not? Sometimes I want to call parents method and sometimes I want to call child's method. Got the question or not? Come on, guess what you're thinking. Possible or not? Yes or no? Yes. And this can be done in two different ways. You can do this in two different ways. Option one, create the instance of parent class under child class and call the methods. Array, we already discussed it day before yesterday, na? What is that? Parent class cannot access pure child class members. Parent class cannot access any pure child class members. Or parent class will not call the child class. See what I said to you in the second rule of inheritance? Child can call parent, but parent cannot call child now. So if you create the instance of the parent class and call, compulsory parent class methods only will be executed, but not of the child class. Check it out. And we are talking about this only about these two methods only, not about these two methods. Overriding and hiding. Now this will call child or parent? Louder. Child. But what is your requirement? Parent. Okay. Create parent class instance. Create and call the method p.show, p.display. Observe it. The first two are parent calls and the next two are child calls. So still you have a chance of consuming parents members. How to call? Create the instance of the parent and call. Compulsory parents methods only will be called, but not of the child class. Okay, now? This is the first option. Second option. Using base keyword also we can call parents methods from child class. But remember, keywords like this and base cannot be used in static blocks. But remember, keywords like this and base cannot be used in static blocks. We cannot use this keyword and base keyword in the static blocks. Why I highlighted you this point is, see, when I say we can call by using base keyword, see, listen carefully. When I say you can call by using base keyword, what you will do now, without creating the instance, in the place of p, what do you write? Base.show, base.display. See, the call is correct only. Base.show, base.display, calling is correct only. But the place where you written this code is wrong. Did you understand me or not? What I said to you? Call is correct only. But Place is wrong. Understood? The place where you return this code is wrong. Why? This keyword, base keyword, cannot be used in static blocks. Basically, these keywords are used to refer non-static members. So they refer to non-static. So we cannot use it in the static block. Then how to call them, sir? Watch. Watch, guys, what I'm doing. I'm writing a new method, public void p show and public void p display. Look at this. I'm calling the two methods, public void p show, public void p display. Now tell me, in the parent, can I call base.show and base.display? No error. Why? These are non-static blocks. These are, now see, you don't require to create a parent class instance at all. Child class instance only will call you parent also, child also. How, sir? C dot p show will call the parent class show method, and C dot p display will call as a parent class display method. And understand, now these two methods are acting as an interface in calling the parents methods from the child class now. They are working like a interface in calling the parent class methods from the child class. How to call? Pay display. But see, no two instances. How many instances are created? One only. There are no two instances here. There is only one instance created. Watch, both will execute. Clearer or not? So one way of calling is create the instance of parent class under child class and call the methods. Create instance of parent class under child class and call the methods. Okay, this is one way how you can do it. Second option, using base keyword also we can call. Using base keyword also we can call. Okay, we can call parents methods from the child class, from the child class. But remember, keywords like this and base cannot be used in static blocks. We can't use it. Where you can use any non-static block. Clear with these two options? Okay. If you are clear with these two options, answer this question, all of you. What is C? Instance of child class. Instance of, I hope you remember this. Load parent P is equals to C. Valid or invalid? Valid or invalid? This is 3.1 of the third rule of inheritance now. What is that? Parent class variables can be initialized by child class instance. So P is called as a reference. Now P and C both are accessing the same memory only. Remember? P and C are accessing the same memory. Class names are different here, not class 1, load parent, not class 2, load child. But C is an instance and P is a reference. Now tell me, using P, can I call child class members? Come on. Using P, can I call any child class members? We learnt about this point, remember? The parent class reference, even if created by using a child class instance, cannot call any, no, wrong. Cannot call any, I said you to remember that word also. You are forgetting again. Pure child class, not child class. What I said? Pure child class members cannot be called. What I said? So using C, we cannot call any pure child class members. Okay, tell me, what are the methods of the child class? Open the mouth here fast. First one, test which takes a integer. Test which takes a integer. Let us try calling and see whether it is valid or not. Say C dot test of 10. Error. See there, you are not able to call it. Understood me or not? Same way, I want to call this method display. C dot display. See, P dot test of 10 is giving error. Okay, leave it. Now P dot display I'm calling. I won't get error.
తెలుసా
Why? Because this method is present in the parent also.
తెలుసా
Now tell me, when I call this P dot display, what will execute? Parent or child?
యాడా
Louder. Parent, undoubtedly parent. Why? You cannot call pure child class members. You cannot call pure child class members. What is called? Parent. Array, same way, we have show method also. Array, I want to call the show method also now. P dot show. We have this method in parent also. We have this method in child also. What is called? Louder. Parent, right? Wrong answer. Child is called. But you said you cannot call. What did I say? Pure child class members cannot be called. I said you remember this word. I'll tell you why. Array, show is not a pure child class method, yaar. Show is not a pure child class method. Why, sir? Understand, man, the method is first declared in the parent class. With the permission of the parent class, you re-implemented the method in the child class now. The parent knows about it or don't know about the method. Tell me, your parents only now given the permission to exchange the dress for you now. So do they know about your exchanging or don't know? No, na? Then how can you call this as pure child class method now? It is not a pure child class. Understand, two options. Pure child class, second one is overridden members. One is pure child class member. Second one, overridden member. What cannot be called? Pure child class members cannot be called, but overridden members can be called because overridden members are not considered as pure child class members. Is it clear? See, without telling to your parents, you went and exchanged the dress. They don't know. Again, you put sad faces. Yeah, I did not tell you rocket science, nah. Common sense only. Okay, so what is that? Without telling to your parents, you went and exchanged. They don't know. But your parents given the permission to exchange. They know. Same thing logic here. See, display. With whose permission did you re-implement? Did the parent give a permission? Huh? Did not give a permission? Huh? That's why it did not recognize the child method. It did not recognize the child method. What is executing? Parent only. But when we call show, the parent has given a permission for the child to re-implement. So first it will check. What it checks? Is this method re-implemented by the child? Is this method re-implemented by the child? If the answer is yes, what it will call? Child. If the answer is no, what it will call? Parent. If you exchange, you wear what you exchange. If you don't exchange, you wear what is given by your parents. Same. Are you clearer or not? So remember this point, guys. Very important. In the rule of inheritance, we have learnt that what? A parent class reference, even if created by child class instance, cannot access any of the members that are purely defined in the child class, but they can access overridden members. See, consider, this is the thing what we already learned it, completed, discussion over. This is a new thing I'm adding now. What is that? But they can access overridden members because overridden members are not pure child class members, as the re-implementation is performed by child class with the permission of parent class. Are you clear? See, you exchanged of the dress here. Option 1 with permission, option 2 without permission. See, listen, you exchanged the dress in two different options you have now. What is the option 1? With permission. Option 2, okay, the day has arrived. The day has arrived when you are required to wear the new dress now. You exchanged with a permission. You exchanged with a permission. So you wore the new dress and came out. When you wore the new dress and came out, what your parents will ask you? Is it the one you got it, exchanged and got it? Yes or not? And you don't have any astonishment in their face now. Because they already know. What is it? You might have exchanged it. You might have exchanged it. So what they ask you, okay, is it the one what you exchanged? Okay, nice. They did not give any permission. You exchanged it. Wore the new dress. Come out. What is the first question you get from them now? Where did you get this? Yes or not? Why? They don't know you exchanged. Their mind is prepared to see you in the dress what they have given to you. Correct or not? Their mind is prepared to see you in the dress what they have given to you. But when they see you completely new gear, they'll ask you this question. Where did you get this from? Understood my point? Okay, exactly the same thing I'm telling you in this context also. What is it? Parent is not ready to recognize the child class display method. Parent is not ready to recognize the child class display method. That's why parent is still calling you the parent's display method. But parent is ready to recognize the show method. Why? Because the permission is given by the parent to the child. Understood? That is why when you call the show method, what it has called you? Child class method. Here what it called you? Parent class method. Watch. Child class, parent class. Now did you understood why I highlighted the word pure child class now? This is a reason for highlighting you that word. What is that? Pure child class members cannot be called. Okay, but overridden members can be called. Understood me or not? What cannot be called? Pure child class. What can be called? Overridden members can be called. That is the important thing to remember. Okay? Listen. Basically, polymorphism is divided into three categorizations. Polymorphism is divided into two categorizations. I'm sorry, guys. Two categorizations. What is that? That can be called as dynamic or static. See, three different terminologies to call it here. Dynamic or static. One category is dynamic, one category is static. Or you can call this as compile, runtime or compile time. Runtime or compile time. Third one. Late binding or early binding. The question can be asked in any way, but dynamic or runtime or late binding, all these three are same only. Same way, static or compile time or early binding are same. But the question can be asked like this in the interviews. What is the difference between static or dynamic polymorphism? Second one, compile time or runtime polymorphism. Third one, early binding or late binding. Just a minute here. Let me bring this first. Option, static or dynamic. Second, compile time or runtime. Third, early binding or late binding. So static or compile time or early binding are same. Second option, dynamic or runtime or late binding is same. So first let us try to understand what is static or compile time or early binding.
Hello.
It's a very important question in the interviews, guys. Understand this carefully. What is static or compile time or early binding? Okay. Method overloading comes under this categorization. What comes here? Overloading comes under this categorization. Okay. See, overloading comes under this category. Overloading comes under this category. That is, in overloading, the compiler
డాడీ
for a method call, for a particular method call, will recognize the exact polymorphic method that has to be executed at the time of program compilation. Read that carefully.
సాయంత్రం రమ్మన్నాడు 9:30 పైన రమ్మన్నాడు ఆయనే చలాన్ కట్టేద్దాంలే అని 2000 తెచ్చుకున్నా
What is that, sir? Look, concentrate on this. This is our first example we discussed yesterday. Do you remember? Method overloading. You defined 5 methods now, and you called all the 5 methods here, right? Okay, answer my question. For this call, which method executes? String class method, huh? Then you're telling, yesterday I scolded you for this, so again you're repeating the same answer. The show method, which takes a string, not a string, don't give one word answers. What it calls? The show method, which takes a string as a parameter. How you are able to say? By looking at the call, I am able to say now. By looking at the call, I am able to say. Yes or not? So you are able to recognize now for which call, which method will execute? Tell me confidently. Are you able to recognize for which call, which method will execute? Just like how you recognized, compiler also will recognize. Just like how you recognized, the compiler also will recognize. When at the time of program's compilation, at the time of, and binds the calls with the appropriate method. See, you called it now. This call is bound to this method. This call is bound to this method. This call is bound to this method. It is binding of now. When, sir? At the time of program compilation. Understood or not? That is only what we call as compile time polymorphism. Misidentification at the time of program compilation. Did you understand me? Identification at the time of program compilation. Are you clear? Sir, then why you are using another 2 words here? What are that? Static, early binding. Yes, guys, the word early binding correctly suits now, see? Are early stages of the programming only. It is identifying now. When is it identifying? Early stages only. When we had written only, it is identifying and binding it now. That's why we call it as early binding also. Are you clearer or not? We call it as compile time also, early binding also. Then why you are using this word static, sir? The reason for using static is, now tell me, this call is bound with a show method which takes string as a parameter. Am I correct? Are there any changes in the future? Come on, answer me. Are there any changes to this in the future? No change. The same method will execute every time. That is why we call static. That is why you are calling it as static. This is static binding. This is a static binding. The same call will be performed every time now, and there will not be any change at all. That is why we call it as static or compile time or early binding. Static or compile time or early binding. Understood? Fine. Now what is the second one? Tell me. Dynamic or runtime or late binding. Overriding comes under this category. That is, in overriding, the compiler will not identify, will not bind will not bind any method with any call. Compiler will not bind any method with any call. And that all happens in the runtime. That all happens in the runtime. What is that? Look, guys. Look at this, all of you. I am calling c.show. Did you re-implement the show method in the child class or not? Past year, already this is declared as virtual in the parent and re-implemented in the child. Correct now? Okay, imagine I did not re-implement. Sorry guys, I did not re-implement this method now. Which one? Show. Okay, deleted. Did not re-implement it. Now see, when I'm compiling the program here, when I'm compiling C belongs to which class? First it will verify in the child class. Or parent class. This is a question. When I call c.show, first it will verify in the child class or parent class. No, parent class. Array, I thought you, man, when you create the instance of a class, first it goes to parent, identifies the members of the parent, then comes to child, identifies the members. First it is going to parent, man. Are you clear? When you call c.show, first where it checks, it checks for the availability of the method in the parent. If not present in parent, then it comes to child. Understood me or not? Okay. Same way I'm calling c.test also. Concentrate carefully, c.test. Now, at this point, what the compiler does? The compiler goes to parent. Finds the method in the parent. Are you clearer or not? Finds the method in the parent. And once it finds the method in the parent, what it is going to do? It is going to call you the parent classes method. Are you clearer or not? Okay, well, just a minute. Now what I'm doing, load parent P is equals to C. What is P? Parent class reference. Okay. Now look at this code carefully. P.test. When I call P.test, where it goes first? Louder. Parent class. Checks for the test method. Found or not? Found or not? Found. Immediately binding is done. Are you getting my point or not? Immediately binding is done. Okay. Now come to here. P.show. Goes to parent. Finds or not? Finds the method, but it won't do binding. So why, sir? Because this method is declared virtual. Because this method is declared as virtual. Now it has to do another verification now. What verification? Did the child override it? For a test it won't do. Why? Test is not declared virtual. What is declared virtual? Show is declared virtual. Because show is declared virtual, when it finds the keyword virtual, it is not going to do the binding at all. Binding will not be performed at all. Without binding, it will leave it like that. Now program compilation completed, but in compilation binding did not happen. Now I am running the code. Now I am running the program. Now tell me, first this line will execute. Afterwards, this line will execute. Now it will come to this line, already binding completed. So it goes there, calls it. But when it comes here, it did not find the binding. Did not find the binding means it is a virtual method. When it did not find the binding, what is it? So now what it will do, first it will go to parent. Are you clear? Yes or not? First it will go to wrong. First it will go to child. Why? When binding is not done, it will check from the bottom direction. Where it goes first? Child class and checks. Is this method available here? Yes, available. It calls it. Not available. Then it goes to parent and calls it. Are you clearer? If binding is done in the compile time, what is the meaning? It is not virtual, man. Binding is done in the compile time. What is the meaning? If binding is not done in the compile time, what is the meaning? Then it will check from the bottom direction, but not in the top, because the first preference should be given to child, not to the parent. First it will go to the child class, finds the method there, calls it, did not find, then it goes to parent. But for a test method, first it won't go to child class, first it goes to parent class only. Are you clear? This is what we call as dynamic or runtime or late binding. Can you understand the 3 words why? Tell me, why are we using runtime? Because the identification is performing in the runtime only. Whether to execute a child method, parent method, all this is happening in the runtime. All this happening in the runtime. Lately or earlier? You're doing it later, earlier. That's why we are using the word late binding. And why you're calling dynamic, sir? Because there is a chance of executing a child class method if re-implemented, or parent class method if not re-implemented. 2 chances are there, child or parent. But in early binding, there is no second chance here. Always same method executes. But here, child or parent. That is why we just call this as dynamic. And because the binding is done in the runtime, it is called as late binding also. It is called as late binding also. So overloading is static. Overriding is dynamic. Sir, what about hiding, sir? As per object-oriented programming, there is nothing called as hiding or shadowing. It is a concept introduced by C# language. That's all. Did you understand me or not? As per object-oriented programming, we don't have anything called as hiding or shadowing. Microsoft got an idea, like why can't we do it like this? And they introduced the concept called as hiding or shadowing. So this doesn't come under object-oriented programming standards also. So that's why this cannot be called as static polymorphism also, dynamic polymorphism. That's a different concept, that's it. Don't relate this to any of the overriding or hiding. Polymorphism as per object-oriented programming is only 2. What are the 2? Overloading, overriding. But as per C#, 3. Overloading, overriding, hiding or shadowing. But object-oriented programming doesn't talk anything about hiding or shadowing. Is it clearer or not? Are you guys clear? Understood static or dynamic polymorphism clearly? If the identification is done in the compilation time, that is called. If identification is performed in the compilation time, that is called static or early binding. Already I'm using the word if identification is done in the compilation time. Means compile time only, na? If identification is done in the compilation time, that is called static or early binding. If identification is performed in the runtime, that is called dynamic or late binding. Dynamic or late binding. So don't be confused with that. The question can be asked either like this or like this or like this. But all 3 same one. Understood me? Okay. So guys, you can see I have, yeah, here I started. First, second, method overriding. The second thing what I said is method overriding. And yes, can we virtual? No. You can do this. Next question. Can we re-implement any without declaring them as virtual? The answer is yes. Why, sir? Because we can re-implement a parent class as method or child class by using 2 approaches. First approach is overriding. Second approach is hiding or shadowing. This is what hiding or shadowing is. Look at this. Class 1, public void display. Class 2, public new void display. Read this paragraph, all of you. we are intentionally defining a new method with the same name and parameter under our. This is not a mistake. This is intentional. Okay. Yeah. In the above two classes, we performed the following. Is what we performed there. Next. In case of overriding and hiding, after implementing the parent classes method under child class, instance of child class starts calling its own methods but not of parent class. Whereas, if required, there is still a chance of calling those parent class methods from child class in two different ways. First option, by creating the parent class instance under child class, we can call parent class methods from child class. Okay. Second option, by using base keyword also, we can call parent class methods from child class. But keywords like this and base cannot be used in static blocks. You cannot use this keyword and base keyword in static blocks. Okay. And then, see, C dot P show, C dot P display, C dot show, C dot display. First two will call parent, next two will call child. Okay. And then read this note. Which are purely defined. Don't forget this word, guys. Which are purely defined under child class. But we have an exemption for the rule. That is, parent class can call or access overridden members of the child class because overridden members are not considered as pure child class members. What is that? Overridden members are not considered as pure child class members because they have been re-implemented with permission from the parent class only. The re-implementation is done with the permission from parent class only. So don't consider them as pure child class members. See the picture. P. Using P, can I call the test method? No. Why? Test is pure child class. Can I call display? No. Display is pure child class. But you can call this. Earlier, 2 days back, what we talked is, we cannot call pure child members. At that time, all are pure child only. At that time, all are pure child. That's why I showed you the picture like this. But now we have pure child is present, overriding is also present. But now also we are sticking to the same point. What is it? Pure child cannot be called. What can be called is overridden. Overridden can be called here. Is that picture clear, all of you? And this is what I explained to you. Polymorphism is divided into two types. Static or compile time polymorphism called as early binding. Dynamic or runtime polymorphism called as late binding. Read it. In static or compile time polymorphism, the decision which polymorphic method must be executed for a method call is performed at compile time. Method overloading is an example for this, and here compiler identifies which overloaded method it must execute for a method call at the time of program compilation by checking the type and number of arguments that are passed to the method. And if no method matches the method call, it will give an error. Compile time only, it will check off and give you error now. Okay, next. In dynamic or runtime polymorphism, the decision which polymorphic method must be executed for a method call is performed at runtime rather than compile time. Okay. Runtime polymorphism is achieved by method overriding because method overriding allows us to have methods in the parent and child class with the same name. Clearer or not? What is it? Runtime polymorphism is achieved by method overriding because overriding allows us to have methods in the parent and child class with the same name, and Same name and same parameters also. Same name and same parameters also. By runtime polymorphism, we can point to any child class by using the reference of parent class. We can point to any child class by using the reference of parent class, which is initialized by child class instance. So the determination of the method to be executed is based on the instance being referred to the reference. Instance being referred to the reference. The reference is referring to a particular instance. So first preference is given to that instance only. Got it or not? First preference is given to that instance only. See the chart. Static polymorphism, dynamic polymorphism. Read it. Acker set, compile time. Second one, Acker set, runtime. First, achieved through static binding. Second, achieved through dynamic binding. Third, method overloading should exist. Method overriding should exist. Inheritance is not involved there, but inheritance is in overriding means inheritance is involved here. Without inheritance, there is no overriding. But overloading doesn't require inheritance. Why? Overloading can be done within a class and parent child also. So overloading doesn't involve in inheritance. But overriding means inheritance. Without inheritance, overriding is not there. Okay, na? Third, happens in the same class. Sorry, fifth, happens in the same class. Happens between parent-child classes. Happens between parent-child classes. Last, reference creation through instance is not required here. Requires parent class reference creation through child class instance. Are you getting my point or not? Did you understand me? Yes or not? Now we need to understand where do we use overriding, hiding. Overloading, already given you an example in the last class only, right line. There is no better example you need for the overloading. What we need to understand is only, sir, when should I use overriding? When should I use hiding? When overriding is used in the application development and when hiding is used in the application. I'll tell you that one. We'll talk on that in detail about that one. But meanwhile, can I define a class in my project that represents a 2x2 matrix? My entity is matrix, man. My entity is matrix. What type of matrix? 2x2 matrix. And 4 attributes. Same rules. Entity is matrix. Attributes are the 4. Why? What do you want to represent? 2x2. It is a 3x3, 9 attributes. 3x4, 12 attributes. 4x5, 20 attributes. That's what you're required to. Understood me? So let me add a class here. What is the name? Matrix. Int A, B, the 4 attributes. Next, constructor to initialize all the 4 now. Public matrix. Public matrix and initializing all the 4. This only I said, you remember what? The advantage of using the same names. What is the advantage of using the same names? It will be clear for you to understand. A value will go to A, B value will go to B, C value will go to C, D value will go to D. Here we have different names. Here we have a different name. It will be confusing. No confusions, no conflicts. That is why always make the habit of using same names to fields and constructor parameters. Same name the parameters so that it will become easy for recognition. Are you guys clear? Simple code and did not write anything great logic here. Simply four fields with a constructor. Now answer my question. Can I create the instance of this class in another class? Forgot already, eh? The day when you started object-oriented programming, we talked, nah. What is that? You can reuse a class by creating the instance or inheritance. Two ways. But now my question is, can I create an instance? Yes, you can. What is the name? Test matrix. What is your plan? Create the instance of the matrix class in test matrix. Static void main. Matrix obj is equals to new matrix, and you're required to pass some values. Yeah, created the instance. And now I'll write console.writeLine obj. Console.writeLine obj. Tell me, will it print me the four values or not? Will it print or not? Print or no? Let us see. No. Array, I already explained you this, man. One day we have EMP.